So in this video, we'll be covering how to calculate mechanical advantages using a spreadsheet. It's a lot easier than doing it by hand. So I'm going to be recreating those spreadsheets, those tables that I had in the other video, and showing you how to fill them in automatically. So let's do this. Let's use the more complete one. So I'm going to use in dist, in force, in pen, out, pen, MA, out, force, dist, alt, and out, dist. Now I'm going to take and make these a little fancy. We're going to go and bold those. So easier to see. So let's start with the 1 inch. I'm not going to put the values in here. If I want to have those available to me, I would take and put the units here. MA does not have a unit. This multiplier also is unitless. And out distance is inches. Okay. So we'll start with 1. So the in force, again, is going to be something just set. In length is going to be something set. And we know we're going to set, this case, we're going to set our out distance to 10. So the first thing we do is solve for MA. The way we can do math in Excel is we hit equals. And then what do we want to delete? To divide? Well, I have an in force and an out force, so I'm going to click on this cell. Slash, and then we're going to go find that one. And the answer is point. Oh, that should be the in distance. So that's going to be A1. We can also modify things by doing it directly. And then to figure out the out length, we're going to use the rearranged formula, which is equal to the out length is equal to the in length divided by mechanical advantage. Or more accurately, multiplied by the distance multiplier. So let's get the distance multiplier. It's equal to 1 divided by here. Our out length is equal to this, is equal to our in length times our distance multiplier. 5, and that's why distance multiplier is what it is. And our out force is equal to MA times in force. So 0.3. So all the tables work the same way. Let's try some different values. So I'm going to use this value here. So in force for 10 pound force. And we're going to do our in and out length. For 12, 12. MA is equal to this slash this. At this point, I'm going to take and untile the tabs so I can see more what I'm doing. Actually, I'm going to change their tiling to be top and bottom. Give it a second while it thinks. All right. That's much nicer to look at. So our in force is going to equal to MA times in force. Nope. Distance multiplier is equal to 1 divided by that, which is going to be 1. Oh, nope, is equal to 1 divided by MA. And if I do a distance, so let's say we had a 3 inch, let's say 12-inch input distance, our out distance is going to be equal to this times our distance multiplier. Nope. So using a spreadsheet makes doing lots of math really easily, because I can take these and solve and do the algebra inside the spreadsheet. So let's say I want to make something that travels really far. So I have some input distance of, say, 1 inch, or say 1.5 inches. And I know I want to be able to I want to move a 3-pound plate 20 inches. So now, the only thing I have two of, I have my input force and or output distance and input distance. I can get MA because I have two of the same thing. So I can do in divided by out. So this slash this. So that's our total MA, which means our distance multiplier I can now solve for is equal to 1 slash MA. And I'm going to need a spring that has the force of, it's in divided by out, so it's going to be is equal to out divided by mechanical advantage. I need a 40-pound spring, and the lengths could be anything, but as long as they're MA equal 0.75. So I'm going to pick an input. Maybe my max size is I only have, let's say I want this to be 18 inches. And my input has to be this divided by this multiplier. I can double check my formula. So 1.35. So constructing the system, if I have a 40-pound spring tied to a 1.35 to 18 lever, the input distance is going to be 1 inches, and our output will be 20 inches. So this is a little bit more abstract. In the next video, we're going to actually construct a tool to bring in your designs and figure out what the total distance multipliers are going to be.